Hey there, today we're going to be looking at paranormal equations. Wait, what? No, the thing was in... Oh. We're actually going to be looking at parametric equations. This is just a set of equations that expresses the points of a curve as a function of one parameter. We're going to just think of this as two different variables that rely on a separate parameter or a separate variable. To illustrate parametric equations, I want to show you my friend Yoon. Now, Yoon is a unicorn, and she loves cliff hopping. Now, usually when Yoon approaches a cliff, she runs at a speed of about 6 meters per second. Now, we can represent Yoon's horizontal distance with an equation, x equals 6t, where t is the time in seconds. Now, when Yoon jumps off of the cliff, she begins to move downward, and this downward distance is affected by gravity. So I'm going to drop some physics on you. Yoon's acceleration downward is going to be negative 10 meters per second squared. Since we know that this cliff is about 100 meters tall, we can represent the vertical position with the equation y equals 100 minus 10t squared over 2. Now don't worry about how I got this. This is just a physics equation, so that's not necessarily the important focus here. So looking at both our equations, we can see that the horizontal position or distance is affected by time, and the vertical distance is also affected by time. So this t is going to be our parameter, and it is going to affect both our x and y values. Our goal is to see how these x and y's relate to one another. So how we're going to do this is we're going to take both our equations, x equals 6t and y equals 100 minus 10t squared over 2, and we're going to make a txy table. Because of this t affects both of these values, we're going to be picking values for t and filling out a table just like you've done to graph different things in the past. So to start, let's go ahead and look at our restrictions on t. Here, we want to focus our t values from 0 to 4. So let's go ahead and do that. We have 0, 1, 2, 3, and 4. Now, to find our x values, we just need to plug in our t values to this equation here. So if we plug 0 in, we'll have x equals 6 times 0, which is going to be 0. If we plug 1 in, we'll get x equals 6 times 1, or 6, etc., etc. Alright, I went ahead and filled the rest of those out. Now let's take our y values. Remember, y is still written in terms of t, so we need to plug in our t values, not our x value. If we plug in 0 in our y equation, we're just going to end up with 100. Plugging in 1, we're going to get 100 minus 10 times 1 squared over 2. That's going to be 95. And I'll go ahead and fill out the rest of these by plugging in my 2, 3, and 4. And there we go, we have all our values. Now when we graph this, our graph is just going to have points x, y. So our first point would be the point 0, 100. Our second point would be 695. Using this to get all of our points, we could use these points to give us a general shape and sketch the graph. Okay, so I went ahead and drew a graph here, and you're going to have to pay close attention on the spacing that you decide to use, because you definitely want to make sure you accommodate your different values for x and y. So I'm going to go ahead and plot these points 0, 100, 695, 1280, 1855, and 2420 on this graph. There we go. Now let's go ahead and connect our points to give us the curve of our graph. And make sure you take note of this. Parametric equations have direction. As our t increases, our graph is moving in this direction. We wanted to indicate that to make sure everything's clear. So what we can do is we can just put arrows in the direction that our points are moving towards. Again, because these are dependent on t, we have to go in the same order that t directs us.